Limiting reactant and theoretical yield. Limiting reactant is between 2 or 3 substances that you react with, those things on the left side of the arrow. One of those is going to limit the amount of product that you can make. So in a recipe, if you have one ingredient that you don't have enough of, it's going to limit making the most of those cookies or pizzas or etc. Theoretical yield is therefore then the amount that you think you can make with what you're given. It's theoretical. It's through calculations. Now, let's look at this example. The way to find your limiting reactant is you convert to the product you're looking at and find the minimum amount made. Then that will come from your limiting reactant. When silicon dioxide and carbon are heated, the products are silicon carbide and carbon monoxide. Silicon carbide is a ceramic material that tolerates extreme temperatures and is used as an abrasive and in the brake discs of sports cars. How many grams of carbon monoxide are formed from 70 grams of silicon dioxide and 50 grams of carbon? So I want to determine how many grams of CO2 I want. And I'm not told anything actually in this equation about limiting reactant or theoretical yield. But I'm given 70 grams of silicon dioxide and 50 grams of carbon. So I'm given 2 reactants and I want to know the information of one product. So this is a limiting reactant and theoretical yield problem. When you're given the amounts of 2 reactants, you have to determine the limiting. To determine the limiting, what you'll do is you'll convert silicon dioxide to carbon dioxide, and you'll convert carbon to carbon monoxide. Then, whichever one makes the smallest, that's your limiting reactant. So here, just like all the other problems, you have to use mole ratio and molar mass. If you want to go from grams of silicon dioxide to grams of carbon monoxide, you know that the only way you can go from here to here is at some point you'll have to use mole ratio. So you need to be in moles of silicon dioxide using molar mass. And then you can go to moles of carbon monoxide. Well, if you want to go to grams of carbon monoxide, you then have to use your molar mass. And the same process will apply to carbon. So plugging everything in, I start with my 70 grams silicon dioxide. Well, I'm going to need to use my mole ratio, so therefore I have to use the molar mass. I want moles, so that goes on the top. My molar mass is going to go on the bottom. Then my mole ratio is 2 to 1. So 2 moles CO goes on the top and 1 mole silicon dioxide is on the bottom. Now my molar mass of carbon monoxide comes into play since I want grams. 28.01 grams carbon monoxide over 1 mole carbon monoxide. Double check. Grams silicon dioxide cancel out, moles silicon dioxide cancel out, moles carbon monoxide go away. You are left with 65.3 grams carbon monoxide. Now, you haven't answered the question yet. You did find an amount of carbon monoxide, but you're not looking for a sum. We're given 2 ingredients here. You can think of 2 substances, and we want to know with this amount, how much can I actually make? That's your theoretical yield. How much will you actually make? But in order to actually determine that, you need to figure out which one limits. And it's not as easy as saying 70 is larger than 50, so 50 is limiting. You need to use the molar mass and the conversion relationships in the equation to determine one is going to limit, so the one that gives you less, that's actually what you're going to make. So we just determined how much 70 grams of silicon dioxide will make. And to actually answer the question, you have to do the same thing for the amount of carbon. So 50 grams carbon, then same exact process. You want to go to moles. So then you just have carbon, you use the molar mass. 1 mole carbon over 12.01 grams carbon. Your mole ratio is 2 to 2. However, you should always double check your balanced equation. I just realized I don't think this is balanced correctly. So I have silicon on both sides here, 1. I have 2 oxygens. I have 3 carbons, so this 2 should actually be a 3. So my ratio from carbon monoxide to silicon is actually 2 to 3. So whenever you're given a reaction, you should always still double check that it balances out. So I have 2 moles of carbon monoxide on the top over 3 moles of carbon on the bottom. Then I use my molar mass again, 28.01 grams carbon monoxide over 1 mole carbon monoxide. Grams carbon cancel out, moles carbon cancel out, moles carbon monoxide cancel out, and you're left with 77.7 grams of carbon monoxide. Now you can see that 65.3 grams of carbon dioxide is your amount that's smaller. Even though that came from 70 grams of silicon dioxide, and that's larger than 50 grams, it made less than 77.7. So 65.3 carbon monoxide is your theoretical yield. That is the amount you think you can make using those amounts, because 1 is limiting. So then you look, well, which reactant did that come from? It came from silicon dioxide. So silicon dioxide is the limiting reactant. The reactant that gives you your theoretical yield is always your limiting reactant. So when it doesn't say specifically calculate limiting reactant, theoretical yield, etc., but you're given 2 amounts of reactants and asked for a product, you have to solve for that. So you have to do 2 big conversions. You're converting one reactant to the other. So we converted silicon dioxide to carbon monoxide. And then the other, we converted carbon to carbon monoxide. Doing the same grams to moles, moles to moles, moles to grams conversion. Then we always had to double check that everything is balanced the way that it's given. So then it's using just all the other concepts learned. When you go from one substance to another, you must use molar ratio. And then you convert what you're starting with and what you end with using the appropriate unit conversions. Knowing molar mass even when it's not given to you, or Avogadro's number, for example, you always have. Then whichever one makes the least amount of product, that is your theoretical yield, that amount. So here, 65.3 is less than 77.7, so that's my theoretical yield, what I can actually think I can make. Now, that came from silicon dioxide, so silicon dioxide is my limiting reactant.